In the last video, this vector had coordinates 3 over 2. But watch the grid. The arrow does not move. Only the grid changes and the coordinates change with it. Same vector, but different coordinates. So, which set of numbers is the vector? Neither one. The vector is the movement itself. Coordinates are only instructions for describing that movement using the directions we choose. The familiar grid begins with two simple directions. One unit to the right is called I hat. One unit upward is called j hat. 3 copies of I hat followed by 2 copies of j hat build the vector v. So, in the familiar measuring system, the vector v has coordinates 3 over 2. Now, let's see where this grid actually comes from. Repeat I hat across the plane. Then, from every landing point, repeat j hat. Each landing point becomes an address, and all those repeated movements weave the grid. It was never a background waiting for vectors. It is built from the directions we chose. Those measuring directions have a name, a basis. And these two directions are only one possible choice. A basis does not have to use perpendicular directions. Its vectors do not even have to be the same length. Keep the vector v fixed. Now choose b1 and b2 instead. The grid tilts into a different measuring language, but the vector v does not move. One copy of b1 followed by 2 copies of b2 reaches the same endpoint. So the vector that was 3 over 2 in the standard basis is 1 over 2 in the new basis. 3 over 2 was correct. 1 over 2 is also correct. Each column is a different recipe for the same vector, written using different measuring directions. The vector itself has not changed. Coordinates are not reality. They are the language we choose to describe it. A basis is a pair of directions that can build every vector in the plane in one unique way. Change the target and the recipe changes, but the two directions can still reach it. In 2 dimensions, any 2 non-parallel directions are enough. But what happens when those directions drift toward the same line? The grid collapses. Points away from that line can no longer be reached. So what part of space can these vectors reach? That is span. This is the hidden dimensions. See beyond the symbols. Discover the ideas.